All right, so we are back here with your last section of notes for the Restless Earth unit. I know it's been a long unit and a lot of notes, but hopefully your notes have come in helpful for you so that you can use them to participate in the different activities and labs of this unit. So last time we left off with talking about volcanoes. This time we are going to discuss earthquakes. Now, I will remind you that we've already previously discussed that earthquakes can often be caused when a transform boundary is scraping. And that scraping of the plates back and forth from each other can cause earthquakes. Now, sometimes these earthquakes can be extremely violent and we feel them, and other times we don't. And something we discussed here in class is the idea that the closer you are to a transformed tectonic plate boundary, the more likely you are to experience more earthquakes with higher intensities when compared to when you are further away from those plate boundaries. So let's define what an earthquake is. An earthquake is when the ground movement that occurs when a block of rock and earth moves suddenly and releases energy. And energy is released as seismic waves. And they occur at the boundaries, like I've previously stated, especially the transform boundaries, which causes the scraping from side to side. And earthquake waves are tracked at the focus of the earthquake. And the focus is the place within Earth along a fault, which is a crack in Earth, which the first motion of an earthquake occurs. So whatever point, whatever crack on the ground the earthquake starts at, that is called the focus. The epicenter is directly above the focus on Earth's surface. So your focus is going to be within Earth's surface. It's going to be the fault or crack in the crust beneath Earth's surface where the first motion occurs. Your epicenter is going to be directly above the focus on Earth's surface. Elastic rebound. Deformation we've talked about in previous slides. And remember that deformation is when rocks bend or break under stress. Recall that breaking creates a fault and bending creates a fold. Warm temperatures cause the rock to bend. Cool temperatures cause the rock to break. So deformation is going to cause these rocks to change shapes. And it's the stress that's put on the rocks by the tectonic plates moving that causes this stress to cause deformation. So because the rocks are going to change their shape, elastic rebound happens. An elastic rebound is when rock returns to its original shape after deformation. So it will return back to its original shape. And what causes elastic rebound is earthquakes. All right, let's talk a little bit about seismic waves, which is how we measure the energy that is given off within an earthquake. So seismic waves are vibrations that cause different types of ground motion. There are two types of seismic waves. They're body waves and surface waves. And then a seismograph is a tool that scientists use to trace an earthquake's motion, and it helps them identify where that earthquake, the focus is, where the epicenter is, and also the amount of energy that's been released, and they can track the different surface waves and body waves of that earthquake. All right, measuring earthquakes. There's two ways you measure an earthquake: by the magnitude or by the intensity of the earthquake. The magnitude is how much energy that earthquake actually releases, which is what we discover by figuring out the seismic waves, by looking at those surface waves and body waves. It's called a Richter scale, and that's what's used to help measure magnitude. Or you can use the moment magnitude scale. That is also a tool that scientists use to gauge the magnitude of an earthquake. Now, intensity is how it's affecting here on Earth. How does it affect our buildings? How does it affect our people? That is the intensity level. And the intensity level is called the modified Mercalli scale. Easy for me to say. Modified Mercalli scale. And this is where you're going to see like the 1, 2, 3, and they assign a number to the intensity of the earthquake. But it does not measure any kind of amount of energy that earthquake is releasing. To measure energy, you have to measure the magnitude. To measure how it affects Earth and the structures on Earth, you're going to measure the intensity of the earthquake. All right, well, that is the end of notes for the Restless Earth. So, woohoo, you're done. Don't forget to hit update on your blog page, and good luck. See you next time.